Hi, welcome back to the channel. Today we're going to be practicing another interview preparation kit question, and this one is about binary search trees, specifically the lowest common ancestor. So this one is fairly straightforward. They give you a tree, and they do all of the logic to create the nodes and to actually format it into this kind of tree. And what they're essentially asking you to do is they give you a root. So they give you the root node of the tree. So in this case, it's 2. In another case, it might be 4. And then they also give you two numbers, v1 and v2. And what they're asking you to do is return the lowest common ancestor, which is basically the node, which is, for all intents and purposes, the parent node of both of them, but the lowest one. So for example, if we were to ask you from 4 and 5, obviously 3 is the parent to both of these. And for example, 1 and 5, obviously 2 is the parent of 1, but it's not the parent of 3 because they're siblings. So you can see 1 and 5 will have a lowest common of 2. And you can see that, for example, here when they give you the root, which is 4, and they give you 1 and 7, the lowest common is 4. It's just a brief explanation of the logic, so we can go ahead and start coding the question. So in this case, let's go with a base case of empty node or empty left right subtrees. So this will be if root is equal to none, return none. If root dot left or root dot right is equal to none, actually forgot. Then what we're going to see is also return none. I could have grouped these, but I just want to space them out a little bit to make it more clear for the video. Now, the next logic that we're going to do is we're going to say immediately if v1 is less than root dot, and the way they've set it up is that the value of that node is, they call it info. Some people call it value or data, but in this case, we're just going to follow their format. So if v1 is less than root info and v2 is less than root info, that means that, for example, if they give us the root and they give us 1 and 3, 1 is less than 4 and 3 is less than 4, so we know it's not this one. So we're gonna say, give me the LCA, which is the lowest common ancestor of our new root is going to be 2, and then v1 and v2 are still the same. So basically, we've essentially already identified that this is going to become a recursive function. Because what we're doing is basically saying if both of the values are less than or both of the values are greater than, then we just use that same logic on the right or the left subtree. So let's go ahead and code that. We're going to say return LCA of root.left and then v1, v2. So it's as simple as that. And then we're going to go ahead and just copy and paste and switch the signs around. Obviously, if both of them are greater than the root info, then we're going to do the right tree because they're now, for example, let's pick a different tree. If we were to say 4 and 5, then we know it can't be in this subtree because they're both greater than 2. So we pass this as the new root and then 4 and 5. So same thing here. So we say, let's comment. Always don't forget to code your code with comments to explain what you're doing. So if both values greater, call LCA recursively with right tree, and this will actually be a comment for the one below. If both values lesser than root, call LCA with left tree. So this will give us both of our values for if both of the values are in the left or the right tree. But if we say that one of them is in one tree and one of them is in another tree, then we know that subtree, then we know that our root is actually the lowest common ancestor. And the reason we know that is because if we know this is our root and we know both values are in here, then this can't be our lowest common ancestor because it has to be something in here. Same thing with the right. But if our v1, so value 1 is in this subtree, the 1, 2, and 3 subtree, and our v2 is in this subtree, then we know that v1 is less than that, and v2 is greater than that, which makes this our lowest common ancestor, as the question states. And obviously, because it's a binary search tree and v1 can't be equal to v2, that logic holds. So there's a couple of assumptions that are made there. Now, if this was just if this was a regular binary tree, this wasn't as strict in terms of the left subtree has to have all values less than the node, and likewise for the right tree having to have all values greater than the node. If that logic didn't hold, if you had a graph, for example, this assumption wouldn't hold. But in this case, due to v1 not equal to v2 and binary search tree properties, the result has to be so let's go ahead and actually code this elif. The result has to be that root is the LCA. So otherwise we say return root. And that's about it. That's everything you need. In this case, you'll see what they're actually printing in the tree.binary search is the answer.info. And what that means is that in the question, they're expecting you to return not the value, but you're actually expected to return the object, which is the node, and then they extract it later. So we're going to go ahead and run just to make sure we have no spelling mistakes. Yes, we do. So that shouldn't be there. Let's go ahead and run that. And we have a little bit of a mistake. So let's go ahead and double check what that might be. And it very quickly becomes apparent that this logic right here is the culprit. If you can guess why quickly, go ahead and pause and try to figure it out. If not, I can give you the answer. And basically, it's this OR. So this is a little mistake. It should not be an OR. It should be an AND. And because if we say OR, if one of the subtrees is empty but the other one isn't, there's still a possibility that your LCA could be, for example, in the left subtree, even if the right tree is empty. So really what our base case here was to check that are both subtrees empty. And in this case, that's not okay, because then that would mean that the root is the only node, and obviously there can't be a v1 and a v2 if there's no children to that root. So that's why this needs to be an AND. And so if we run, we'll see that that passes. Then let's submit the code. Passes with no issues. So that's basically how you do the lowest common ancestor of two values given the root. If you have any questions, please feel free to drop those in the comment section if I missed anything, or if you need any clarification of why this was done a certain way. There's more than one answer, but this was done obviously in Python 3, but most of the logic applies in any other language. So yeah.